Cool, cool, cool. Hello, hello. We are back at Solving the Advent of Code 2015 with Rust. I mean, it really doesn't matter that we are solving it with Rust, but I just wanted to challenge myself. The next exercise, or the day, is the 9th, which is all in a single night. Every single year, Santa manages to deliver all of the presents in a single night. This year, however, he has some new locations to visit. His elves have provided him the distances between every pair of locations. He can start and end at any two different locations he wants, but he must visit each location exactly once. What is the shortest distance he can travel to achieve this? For example, given the following distances, this one's possible routes are there for. So this is a permutation thingy. Whenever we will create a linked list-ish thing and adding the values together. The shortest of these is London, Dublin, Belfast. Oh, I see. So there are different, set of what is it? Ooh, we will do a little bit of a drawing. So coming back to Excalidraw, no, not this one. So as far as I understand, there are different locations, which are the cities, and based on what the input is, we should come up with the shortest route. What is the distance of the shortest route? But between when this is the question itself. So the thing is, Santa can move from different places, and we will store what the different distances are between those cities. So the question is that they are not even providing us the starting and the ending city, because it is not even the question. The question is, what is the shortest route? Because it might be different with each of these things. So the provided thing probably in the puzzle, which we will soon read, but I will just open this up. Yeah, it is that much. And the question is, what is the shortest route? So to evaluate the shortest route, we have to go to all of these things, and we have to evaluate with all of the starting and the ending points. I mean, we have to evaluate one algorithmic thing. So there will be some cities, and there will be some what is it? Routes or distances between those. But those are not that type of things, but this is just from one place to another. So we are not allowing distances to be backwards. So London to Dublin is that much, but is it Dublin to London as well? Dublin, London. Dublin to Belfast, London to Belfast. Give me a second. So the possible routes. So this is a two-directional relation rather than a directed relation from London to Dublin, because we want to go from Dublin. Can we go from Dublin to London? Yeah, from Dublin to London, it should be this thing. And whenever we add that value to it, yeah, so this is a bidirectional relation. I thought that this is just a route between cities or locations, and you can only add those together. But based on the description, probably. And hopefully this is a bidirectional relation, because this is just a distance measurement, and the distance should be literally both ways. Cool. So this is not even a bidirectional something. This is just a relation between the. I mean, this is a bidirectional. I mean, from that place to that place and backwards is the same distance. So as you can see, this will be, or this is actually, a graph with roots between those. And we will create a graph or not, but we will see. And hopefully, I mean, this is not by design, as far as I can tell. What is it called? A complete graph? What is it called whenever... so there should be no isolated subgraphs of it. From one place you should always be able to create a route into another node as well. But the question is, do we have a route always to another city or not, or that location? Because this is, I mean, this will be soon a full one. This is a full one because you cannot just create a path, but there is what is it called? There is a relation or an edge to one place to another as well. Cool. Yes. So the question is that how should we read our data to implement that thing? So the shortest path. What does it mean? What is the shortest path? What is the question about? What is the distance of the shortest route? So, yeah, we should be able to touch or go through every city in this drawing. But the question is, which is the shortest path? So, this will probably be a shortest path algorithm. Maybe, but without specifying the starting node. Or we should evaluate all of the node as a starting node and calculate what is the shortest path and get the minimum of those, of that things. The shortest path for all of the nodes. Whew, let's see. Let's open up the folder and we will jump right into that thing. Cool. So yeah, we will just copy this thing, which will be 9 tests. We will copy and paste everything from here like this. Yeah, so this is 9 test, and we need the 9 prod with the content of the, I mean the input of the puzzle. Cool. Which is this thing. As far as I know, with this thing, yeah, it's not the easy. So there are puzzles. I mean, I heard about puzzles which are easier to evaluate by hand, by looking at it and not programmatically. Probably this is not the case with this one. Alpha Centauri. Wait. Is this a Stargate reference? Whatever. Stray Light Arbor. Whatever. So we have to first of all read these things. So before doing huge magical things, let's create a ninth one and create all of the interesting parts here. So we don't need this whole helping function things here, but we want to create this thing. I'm not sure about this thing, but we will see. And there is one more thing here that we should include and change these things like that. One more thing that I have seen. So instead of doing these interesting things, these whole functions, I've seen people creating a macro to do all of these interesting things. And maybe we will do some other stuff as well. So we don't have errors, which is always a good thing, but it's kind of doing nothing yet. Cool. Yeah, we added 3 new files and that's it. Chore add 2015. I said 2015 9th day scaffold. Cool. So what's going on here? Looking at the file, the input file. Oh no, that's not the thing we need from this part. We need this thing. Yep. Oopsie. Yeah, let's fix it here. Git add, we change the content of this thing to that, and we want to amend this. Yeah, no edit. Yeah, so we rewrote the content of the previous commit and kept the commit message. Cool. So somehow we should. So what should be my approach here, or thought process? So we have this file, 8 tasks, and we should create first of all a structure which can represent this thing, whatever this thing is. So we have what is it called? An origin, origin and destination, or from, to, and will that be always an integer? It seems like, and a number, let's say. Yep. And it should be the other way around as well. I'm not sure if I wanted to create simultaneously a Dublin to London with that thing, but yeah, we will see. So there should be a struct something which should be a distance, which should have a from, to, and the distance. In it we should here we can implement a constructor, but I'm rather interested in how to parse it from a file. So we should implement the try from with the stir reference for that given distance thing. Yep. And we probably should implement this something. Let's see. So yeah, looking good. So we should actually specify the so that should be a string. Once again, so this trait implementation will allow us to literally try to map a string into a distance something, and because that's a try from another try, it can throw an error, and we should... I'm not 100% about this thing. Unwrap to owned, the distance, split, and... Well, yeah, let's give it a try. So in the tests, that's a really good small test to create something like this. Create test the distance parse. Parse, yeah, just like that. We should yeah, so in this thing we should create London to Dublin. It should be London, Dublin, and this thing. We should run this test, and we should see that it is okay or not, and it is indeed okay. So it should work. I wasn't sure about this. Oh yeah. So this is a split something which is similar to what is it? Which is similar to an iterator. This is pretty much an iterator as far as I know. And whenever you consume the nth, so these elements are not the same, but those are called with the next two times, and you will step on the string itself. Cool, looking good. So yes, so it is working. I'm still not sure if I should create the other way around as well, because it would make sense whenever I would create a graph or something like that. So how can I actually, there should be one function here to read all of these things into a vector. Get distance. No, I don't want this yet. Read distances, and there should be a content, and yes, we want it to map. Ooh, there's an unwrap. Risky thing, but they promised us that the format of the file will be just like that. Cool. What else? So yes, so we should come back and to see how we want to approach this thing. So the shortest path, and whenever you're creating an algorithm, is not a big scene to start it out by smaller things. So whenever we have 3 of these things, how should we approach that stuff? So there should be one function which can evaluate the shortest path from that thing to another. I mean, to the shortest path. Just an interesting, because you have to go through all of the things. I mean, the current question is, whenever you have 4 paths here, and if we have to touch everything, so this is the starting point. Let's call it A, B, C, D. I mean the nodes. It's not the C, that's the D. So the question is that how can we evaluate which is the shortest path to a given Dublin, London. So we have to go through all of the roads or the paths and evaluate which is the shortest when you are consuming all of the the nodes. So you have to, so yeah, we need a function shortest, which will get a node. Yeah, and we'll return with I don't know, a number probably, because these directions have a number value. So it should be a number, whatever that number is. So in this function, we should check all of the outgoing directions for A's neighbors, and we probably should return. Oh yeah. So these what is so these pathfinding algorithms are actually really famous, but the question here is, do we have a pathfinding algorithm when using every node? This is my question. No. Certain nodes, almost. We need to touch all of the nodes. Oh boy, Floyd Warshall. I got already PTSD from this thing, because I learned about this interesting thing, I don't know, 10 years ago, something like that. So yeah, it's definitely recursive, but does it say many possible paths through the gap between each pair of vertices? How can we ensure that we would then we are consuming or going through all of the nodes? That's my question. Yes, no. Yeah, but yeah, Dijkstra is not bad neither, but this is just evaluating the shortest paths. Yes, we got a lore and such, and yes, thank you, but it never mentions or says that. Cool. So we left off reading the distances, and my guess is that I really should rather not just return with one instance of this one, but rather should create. Yeah, I mean, if I would create a bit more complicated data source, I mean, this is my initial guess, then not just a distance vector, but rather a hash map, and evaluating all of the possible routes, maybe I would win here a little bit. Let's see. So, as I said, maybe and probably I should read not just the direction from one place to another, but at the same time I should probably read the other way around as well, because I probably need it to evaluate um, the what is it? The distances between locations. So this is the read distances, but I might have let's call it read content for now, and I should rather have an have or store paths or something like that, and we should return rather. No. I mean, I need distances, and I just wanted to create or return with a hash map rather, way which would contain the inputs and the outputs as well. So we need something like a hash map with the string key, which is the current location, and we probably should have use another hash map in it. Give me a second. So yeah, we might say that this is a routes of a map, yeah, and this is a hash map, but by the map I didn't mean the hash map by the map, and we might use hash map here as well. Give me a second. So this will be an unsigned thing probably, because there is no negative distance, and yeah, 64 or just usize, we will see. So in order to create this thing, we should no, we need this. So we can read this thing, and this should be a routes map. Yeah. So we should go through all of these paths, and we should add not just from one place to another, but on the other way around as well. Jesus Christ, what is this? Okay, thank you, Copilot. So I want to go through all of the distances from to distance. Yo, looking good. What's going on? So this distance is a struct, which we already know, which should have 3 things in it. This is an iterator. Okay. And I cannot do the destructuring thing here. This is an iterator which items type 9 distance. Let's just say distance of this distances, and we want to say let yeah, so we destructuring things here. I'm not sure if we can or we cannot do this here, but we can obviously do it here. So the question is that what should we do here? Because we want to say from and to, because we want to store things the other way around as well. So let's format this thing a little bit. So yeah, we need to create a hash map if no entry is present with that get or oh yeah, we stored something else. It can be a usize and not an I32, because it doesn't make too much sense to store negative distances, I guess. And we should just put usize here as well. So no mismatches here, hopefully. Yeah, things are moved. So let's worry about the first part. So here what happens is oh boy, yeah, let's rather add these things. Yes, so this roads thing, and whenever we are iterating over these distances, we wanted to insert the source or the destination as location. So we are doing it with the 2 in the beginning, and we are adding we should add what? Yeah, we are inserting the distance from map distance. Hash map new. Yes, and after that we should say that there should be a key with the 2, hopefully, because we just inserted something here. And there we should say that, yeah, this thing exists here. What's your issue? Behave. No copy. Okay. So this is a string, and the get stir, get mode. What's your issue here? I wanted to insert expected reference. I can give you a reference. What's your issue now? Does not implement copy trait. Again, what should happen here? We need to create values with the from and the to, right? Oh, or insert hash map new. Yeah, that's looking good. And we might say there should be a to map as well. And to this thing, yeah, looking good. And after that, since these things are created, we are able to insert into these hash maps. But why am I not? Oh yeah, so, or insert. So if there would be no hash map yet. Yes, so insert to clone distance. Yeah, it moved. Yes. Not implemented copy trait. Looking good. So the interesting thing is what? 2. Yeah. Silence. Thank you. So we have a reference to this thing, and that's a new hash map which is inserted under this key, and we should be able to insert from a map. We should insert under the key which is added, which should be the from, and we should be able what's the issue here? Cannot borrow routes. Oh, yeah. We cannot have multiple mutable references to that thing, which makes sense. Uh-huh. Mm-hmm. Man. Mm-hmm. Hmm. Hmm. Mm-hmm. Give me a second. What's going on? Let's go with the more... what is it called? Atomic operations rather than inserting with mutable references. So yeah, so if the from is not in the roots already, just create one. We should have it pretty much the same, but with the to as well, because if no London is present, and from London where can we go, then it should be added to the roots. No distance is provided yet. So whenever we added both of those, we should say, yeah, we want to mutate these routes, and from, yes, and we should say, we know that thing exists, and we should insert a 2 and the distance. Because from London to, I don't know what the thing was, we wanted to add this. What's your issue here? Yeah, looking better. So this is the one place to another with that distance, and we should do the other way around as well. So routes dot get mut with the to reference. It exists because we just created it. If it would not, yeah, what's your issue? Yes, and we probably should have a copy with the two owned here and there, because it will no longer need a reference. Yeah, looking good. I mean, what we've just done, we created a rather hash map-ish thing instead of the vector, and now we can say from the, what is it, from London, with the possible directions from London, we stored what's the distance. Oh boy. Yeah, so we are, let's call it evaluate path, because we are evaluating the path. Question mark, we will see. And yeah, that's kind of it. So let's see what's going on. So somehow we have to go through and evaluate the length of the routes, the longest routes, right? Yeah, the longest paths from the nodes, or the original, or the starting locations. So there should be another function, not get all routes, no, but it should be, let's evaluate the length. So we should, yeah, get routes, lengths, I'm not sure, dos, hello? Yeah, twos, yeah, no. So we should go through the routes, and we should iterate over those, right? Or we need the starting locations, and we should say something like that. Oh, What? I thought that I have to write it myself. So this permutation thing is yeah, we need to go to all of the remaining destinations. So probably we should say yeah, routes, keys. Can I say that? Yes. And that we need that much permutations, because these are the possible ways where we can go, and we should create things based on that permutation. Yes. Let's see what's going on. So this permutation will be let's rewrite this thing instead of Copilot. So this permutation is a vector of strings, because this is the place where we can go from this key. So from this location there will be possible directions that you can go, and we should say, we should evaluate, yeah, a length or a path length from the thing. We should, oh my god, for let's say there is a route in that permutation. Why can I not have a reference to this thing? Permutation, almost. So we need, hello? What's going on here? Permutation, oh, we need to open a function block, I guess. Looking better. So the permutation, and we can access some vector methods here as well. So what do we need here? So we need to get every pair, and we have to get the distance between the these things, and there is the Windows thing, and this Windows things will mean that we need every pair, and we need to we want to reference it somehow. Yeah, and we want to add something to this length above, which is, yeah, so from the routes we want to evaluate what is the value of that thing. Yeah, okay, and we need to okay, coming back here, we need these routes. That's one thing. Yes, what is the issue here? Expected the struct vec, and oh yeah, because we have a we have to collect it back. So what happened? We went through the routes, we evaluated based on the keys, which is the starting points here. Where am I? So we went through all of these starting points. We went through all of the keys, which are the starting points, and we said there are pairs in the routes, and whenever you find the permutation, which are the possible connection or conjunction points of the graph, add those things together. But since these are these are coming in pairs because there is one starting and ending point, please add these things together and move in pairs. And we just collected all of the outgoing points, or we collected the length, basically. We just added these things together here, and we collected. So the routes should represent a vector of u size based on the minimum, I mean the starting points and adding the distances together. Oh my dog. So what should happen? So the solve first should be this length something. We should somehow evaluate the roads. Okay. Read content is returning with a distance. It is evaluating that hash map. Am I correct? Hello? What's that thing until this point? Get routes? We don't have get routes. Oh, it's evaluate paths. Evaluate paths. What's your issue? What's your issue? Stop. I'm doing things. Yes, and we should say min. Min, because we want to get the looking good, looking good. We can say this this. Ooh. So what happened? We read the content into a vector of distances, we evaluated this hash mappy thing, we generated or created the length, and we want the minimum. Oh, the longest path rather. Okay. So let's do a cargo test and let's see what's going on. Obviously it will be an error. The question is, what is the error, and what can we do about it? So okay, get mut. Oh yes, that's the issue. We should create two and from, and not just from and from. Yeah, that makes sense. Yeah, so it's no longer I don't know, what is it called? It's just a test mismatch on an assert. So let's see. So instead of that 12 here, it should be 1982, which is wait, we are looking for the shortest. Oh, the shortest, not the longest. This is the longest. Jeez. We need the shortest, which is we have to change 2 characters here. Min, not mon, min. Yeah, looking good. Come again, please. It should be A605. Looking good. Oh my god. Getting closer. Yeah. Looking good, looking good. And it is not 100. Yeah, it's 117. I'm not sure. Oh, maybe this is the. Okay. Looking good. Let's try this value. I'm not sure what this thing is. Ooh, damn, looking good. Let's. I just don't know what happened. I mean, we evaluated the things, what they expected. Yeah, no longer 2. It will definitely fail. Yeah, commit, feed, 2015, day 9, first solution. I should definitely come up with some naming convention here. Okay, interesting. So yeah, so what's the second part here? So the next year, just to show off, Santa decides to take the route with the long. Excuse me. Okay, then it should be probably the 982. What it was before? Yeah, 982, and whatever number will come here will be the thing, and we should do some insane copy pasting and change it to Mux. And yes, you're absolutely right. I should do some refactoring, but I do not care. It looks good. So the number should be 909 instead of this thing. Let's run it again. It should pass, and we should just copy paste this thing here, and we will get a golden star. Cool. Looking good. Meet you in the next one.